building a TodoMVC from scratch with Rust as a backend, Postgres as a database, and native web components for the frontend. Okay, let's code. Now in this project, we are going to have two parts. First, the frontend with our package.json. And for now, we are going to keep it empty like this. We'll do the frontend later. And then we're going to have our backend with our cargo.yml. First, we're going to have our Tokyo for everything which is going to be async. We'll be using some future trait as well. And then we're going to use this error that will remove quite a bit of boilerplate for errors. Then on the JSON lib side, we'll be using the CRD crates. On the web libs, we'll be using warp. And then on the DB libs, we'll be using SQLX for DB executor and sqlb, which is actually a little experimental SQL builder that I've been writing, but this is completely optional here. Okay, so now we're going to create our source main.rs. Very simple hello world. And for now, we're going to mute the warning as we're going to build the code, and then eventually we'll comment this out. Press save, and then backend folder, we do a cargo run, and run our hello world. So far so good. Okay, so let's focus on this file only here for now. Our application, we are going to have three main modules, and that is going to be the model, which is going to be our model layer or data layer in a way. And then we're going to have a mod security, and then we're going to have a mod web. So that is going to be the three modules that we're going to have. And for those, we're going to create a folder for each one of them, because we're going to have more than one file. So we're going to have model.mod.rs. Then we're going to have security.mod.rs. And then we're going to have web.mod.rs. Focus on is our model layer, our data layer. And we're going to create here a README file where we're going to put our command line. And so for the database, we're going to use our Docker run. We're going to use the default Postgres port. And then the password of the Postgres user, the root users, will be Postgres. And then we're going to use Postgres 14. And then eventually, optionally, we're not going to really use it here, but we can, in another terminal, do a Docker command like this, such as we have a psql command on this database. So now that we have that, we're going to copy this, add a new terminal, name it database, such as we don't get confused later. And then here we paste this command line. And that will create a database here that we can connect to. And now we can go back to our command line here. So now we're going to close this file, we go back to our backend, and we're going to create our first submodule, which will be just a DB here. So the first thing we're going to do is define a type for our database. And so the type here will be just a type alias DB, which will be the pool, and that will be a SQLX object of Postgres. And both of those are SQLX types. So we're going to import them here into our application. So the first thing we're going to do is create a new method, a low-level method just for this module, which is going to create our new DB pool. It's going to take the host, the database name, the user, the password, and the max connection. It will return the result DB, and for now it will return the error of SQLX. We're going to create our connection string. This is the way that SQLX works. Format is going to be Postgres, the user, the password, the host, and the database. User, password, host, DB. And then we're going to use the PG pool option from SQLX to create the database pool. We are going to give the max connection here. And then the timeout will be hard-coded to 500 milliseconds. And then we give our connection string. Press save, and everything should be fine. Now our application will not call this method directly here. That will be too much information for the rest of the code. So we just have a pub async fn init db. That will actually recreate the database all the time, but obviously in production, that will just create the appropriate database pool, such as can be used in the rest of the code. It's going to return result db SQLX error, and that will just call new db pool And because we want to be a little bit organized here, we're going to have some constant to define the root DB properties for now. And then later we're going to see how we do the application one. And we're going to add those here to the function parameters. For now, the max connection pool here will be 1. So now we're going to do our first unit test. So it's going to be a blank one for now. So it's going to be the config test, obviously. We're going to use our init method, the public one, for now only. And then we're making sure that we're using Tokyo test, because it's going to be async. And then the convention here, which will make more sense later, is repeating the module path here. So we have module underscore DB underscore the name of the function. And then eventually they could be also suffix to have the different states of the test. And now we're going to run the test. But for that, we're going to use cargo watch. So we're going to have a cargo watch, -q for quiet, -c for clear, -watch, we're just going to watch the source folder because we're going to change other files and we don't want to restart the server all the time. And then we have the -x for execute. So that will do a cargo test. That will be our filter. So that's the reason why we have this naming convention. You can have your own strategies. That's completely fine, obviously. And then we're going to have two other parameters, which you have to give with --. One is to make sure that we have a thread 1. And that is because we have all these database and we're going to create and recreate database. And so to make sure that things doesn't work on each other, we're going to run them as a thread 1. Making them multi-threaded is possible, just more work. And for now, we're just going to focus on that. And then the next little trick here is to have a no capture for just development. And that allows us to have some println so that we're going to see what we're going to test. And then we replace the println by the asserts, and then everything is tied. I'm going to select this and I'm going to copy paste here. That should run completely fine. And it's normal because we do not have anything here in the test. So this one has to succeed, but at least everything is compiling fine. And now the only thing we're going to add for now is just this initdb. And if it doesn't fail, that at least the connection works. So we're going to press save and everything pass. One personal preference that I have is to have the unit test in their own files. It's clearer for me. So the way that I do that is I take the content of the test and I'm going to create a folder here. And my convention is I'm going to put them under test. And then the name of the file is going to be, again, a flat name, model_db.rs. And then I put my test here. And then the trick here is I go back to the DB, and Rust has a cool attribute, which is path. And then I can put a relative path like this, model_db.rs. Now I press save, and everything runs as before. But now I have my cool _test folders where I'm going to have all my tests. Sometimes I might put them into a hierarchical kind of folder structure, but at the beginning I like to have them flat. It's very easy to see what's your test. And again, because the test convention here, we're always repeating the module tree, then I can test very easily whatever module tree I want. Okay, so now it's time to create our SQL database. So the way that I like to create it here is with SQL files. So what we're going to do is we're going to create a folder, SQL, and inside the folder, we're going to create the first file here, which is going to be 00, and we're going to order them like this, recreate DB. And by convention, the 00 is going to be run as a Postgres root. We're going to first drop the database, and we're going to call our database appdb, and we're going to drop the user. Again, this is only for development, obviously. And then as it matures, then you don't have this way, you have an incremental way of doing with the schema that you have in production. But for early development, this is very, very fast. And then we obviously create the user, app user, with any password you want, and then the appdb. And now we have our first recreateDB SQL file. And the second SQL file that we're going to create is going to be a 01 create schema, and we will run that as the app user. First, we're going to create a to-do status enum as a Postgres enum with open and close. And then we're going to create our table to-do with the ID, which will be our serial number here, and CID and CTime. By convention, the CID will be the user ID of the person that have created the to-do, and the CTime is a time of creation. So here we are just going to default it to now, and it won't even have to be part of the CRUD API. And then we have the title, and then we have the status with the enum that we have just created, and that will be a not null, and the default will be open. Now a little trick here, we start all our IDs, the ones that are here, we are starting them at 1000. This way here, when we do unit test or whatever, if we are below the 1000, we know that when we create it with that ID, it won't overlap. In this episode here, we're not going to really create the user table. We should have a user table with the CID, but for now, we just have that, such as we can show the pattern in the code later. And now the last file that we're going to create is going to be more kind of a dev file, and that will be our devseed SQL. The first thing we're going to do here is create a first to-do. And again, we're creating with an ID below 1000, such as it doesn't overlap with the sequence number. And here we're going to specify the status, and we're going to make it close. And just for the sake of it, we're going to insert another one. And this time we're not going to include the status, so that will take the default status. And the convention here is the title will be just to do and the title ID, such as we can write our unit test like this. And now we have all the SQL file we need. Now we go back to our DB file here, and we're just going to focus on this file for now. So now we want to create a function that will execute our SQL file. The first file will be executed as a PG root, and the two other files will be executed as our PG app. So it's going to be relatively simple. We do our async, fn, pexec, it's going to take a DB, and then our file, which will be just a string, is going to return result, void, if it's okay, otherwise our SQLX error. We're going to return the OK state to make sure that it compiles. So the first thing we're going to do is read the file. Very simple, we'll use a read to string function from the fs module. We're going to make sure that we import it. And then we're just doing a map error to print the error message in a nice way. And then we just cascade the exception back up. And so this is why we have the question mark here. So this will return exactly the same error if there is one, which is a SQLX error. Then we're going to split the SQL files in SQL statements. So that will be a vector of str. And we're going to do a Pullman splitting right now, which is going to be a content split on semicolon. And obviously here you might want to do a little bit more sophisticated, because if you have other semicolon as values or comments, it will break. Okay, so now we are ready to do the iteration on our statements. So we're going to do a for SQL in SQL S, which is our array. In SQLX, the way you execute a statement is with a SQLX query. You give the SQL string, and then you call execute with your database pool, and you call await because it's async. Now, what we want to do here is each statement, if there is an error, rather to stop, we're just going to println. Again, this is for development, and in production, again, that might not be the right way. So we're going to do a match. If it's okay, then we're happy. So we're going to return void. And if there is an error, we're going to print, and just a warning, pexec, SQL file failed. And then we're going to give the cause, which will come from our SQLX. The file, ex, comma, and then that's it. Press save, and everything should compile. Now that we have that, we can close this function, and we're going to focus on our initDB, and we're going to define some other constant here. The first ones are going to be the appdb information here, so all of these ones. And obviously that will come from probably config files or environment variables if you deploy on Kubernetes. but right now we're just putting them as constant. And then the other set of constant we want is our SQL dir, which will be our SQL folder, and the SQL we create, which will be the only files that we run as a Postgres user. Now that we have that, we're ready to implement our AnyDB. So this last line will actually be returning the appdb, but for now we're going to keep it as pgroot, such as we compiled and everything run nicely. And then the first things we're going to do is we're going to create our application database. And so for that, we're going to have our rootdb database pool, which we create the new pool here, and we just need to have a maximum connection of 1. And then we're going to call our pexec we just created with the database, the rootdb, and the SQL create. So that will create the user and the database. Press save to make sure everything works. So far, so good. Now we can return the pgapp rather than the pgroot. So here we're just going to change with pgapp. And the mass connection, we can use our constant. We're going to press save, and everything should compile, and everything works here because we have a valid connection to this new appdb pool. So we didn't create the schema. We're going to do that now. Run the app SQL files. And for this, we're going to create an appdb. So just copy this one. I'm going to copy that here. Just by app. And that will be our appdb. And this is just connection pool just used to create the files, to execute the files. Then we're going to read the directories, the SQL dir. And we're going to iterate. And we're just going to extract the path. So that allows us to not have too many kind of enum, nested enum. And that will give us a vector of path buff. We have our path mute because we actually want to sort it to make sure we have the SQL file in the right order. So that is our best practice. And then we're going to execute each file. So we are going to iterate through all the path buff that we have. Then, if it's a valid path, a valid string, we need to accept only the .sql and not the recreate. So for that, very easy, we do a path if path ends with .sql and path not SQL recreate. And then we're just going to call our pexec appdb and our path, which is a string now. We're going to await, and we're going to do question mark here if there's an error. We'll stop everything, which usually most of the error will be kind of swallowed by the pexec, the way we coded it. And we're going to press save. We forgot to import the path buff. We're going to press save, and everything should compile, and everything should work because we didn't change anything. We just executed some files. So our SQL files are valid, and we are returning now the appdb. Now, if we go back to our model_db test, we can do a very simple test. So our best practice here, that is the action of the test. And the check, we're going to be a very simple check, which will be result equal SQLX query. So that's the way SQLX works. And we can do a select star from to do. We're going to fetch all, and that will return pgrows array of our DB. We're going to await, we throw error if there is one, and then we want to have an assert, and we're just going to check that we have two to-dos. So far, so good. Result, length, number of seed to-dos. This is our message to make sure we know what we tested. Press save, forgot a T, press save, and then boom, everything works. It might look a little bit over complex, but actually when you start like this, you have a very fast way to iterate through your code. Because now you can change your SQL files, press save on your RS, and everything will be recreated and your test will be rerun. And we'll see how later this is going to be very convenient. Okay, so let's do some real work now. So we can close these files, and we can go to our model mode, and we're going to create a new mode now, which is going to be mode to do. And that will be for todo.rs module file. Press save, and everything should work. We can probably stop the Kaggle watch for now, and we'll restart it later. So now we're in business. So first we're going to create our to-do object. So it's going to be a public struct to-do, and we're going to have ID as 64, which maps to the big int in the database, our pub CID, which is also big int, so that will be our creator ID, and then our title, which will be a string, and it will have to be on, obviously. One thing I like to do is to create region, and so this one will be the to-do types. So like this, I can collapse the code like this, and can have all my types here, and then collapse them. Press save. Now we're going to add some derive, and the first one we're going to do is called SQLX from row. And that will allow SQLX to make this magic when we do a from or a fetch, then SQLX will do the magic and will return this structure here. So it's very convenient. And we're going to make it debug as well and clone. For now, we're not going to have the status. We'll show how to do the status later. So then after, we're going to have another region, which will be for to-do Mac. And Mac in our world here, in our pattern, is model access controller. It has a similar pattern as a DAO, but it's using the Rust construct here, which means that they don't really need to be object. They can just be a struct with some associative function. So for that, we're going to have our pub struct to-do Mac. Doesn't have to have any properties. And then we're going to implement our first cross method, which is going to be the list. So we do a pub async list, and that will take our DB, which we'll import, and it will return a vect of to-do. And for now, it will return SQLX error. First thing we do is we create our SQL query. So select, that will be for now a row query, CID, title, from, to-do, order by, ID, decreasing. So that will order reverse, which is usually what you want for this use case. Then we are going to build the SQLX query object, and that will be with query, SQLX query as, and we do the turbo fish here. This one can be deduced by the compiler, and then we're going to give our to-do, and we're going to give our SQL string, and then we're going to execute the query. So the way it works with SQLX is you take the query object and you do a fetch all DB and await. And here I'm going to toggle the types inlay from Rust Analyzer, and we can see that we have a vector of to-do, because here we say query as, and we gave in the turbo fish, we gave the to-do type. That is the way SQLX is coded here. And we can do a fetch all, which return a vector, or a fetch one, we'll see later, that return only one. And now we can return our to-dos. Press save, and everything should compile. Or at least Rust Analyzer didn't complain. Now, in fact here, because we return the vector of to-do, the compiler will have enough information once we have this statement here. So in fact, we can remove the turbo fish, press save, and everything should work. And if I toggle the type inlays, I will see the compiler deducted that was going to be a to-do type. And we're going to use the same pattern that we used before, which means that we're going to put our unit test in another file here, which will be inside model todo.rs, which is going to be a model todo.rs. So we're going to create our first test. Very simple. We do our Tokyo test. We have our model underscore todo underscore list to follow our best practice. As a fixture, which is basically the setup of the test, we are going to have our DB. The action of the test will be to call the to-do Mac list with the DB and the await. We're going to make sure that we import the init DB, and then we import the to-do Mac. And then for now, the check will be a very simple check, will be assert equal, and for now we are just going to check how many items, which will be 2. We're going to press save, everything should compile, and now we are going to do our cargo watch, but rather to have our model underscore DB, we're going to have our model to do. And we can do the list, but then we'll keep it this way, and then we'll see how it goes as we add more tests. We're going to press save, and boom, sometimes it's almost too good to be true. What we can do is a println. We're going to have this way, it looks better, and then it's going to be the debug, and we do our to-dos. Press save, and then boom, we have our 2 to-dos here. It's coming from the database. So obviously we can remove that, and we can add more tests. So for example, we can test the to-do 101, which will be the first, since we go from last to first. And then we can do the test for to-do 10, which should be something like that. Now we press save, and everything should pass, and everything is tight. So here we created the test data in the SQL. That is a strategy that can be debatable, but it's just to show the context. You might have here in your method having an initDB or a seed test DB, and then testing this data from the test rather than something from the outside. But this is the gist of it. So this is pretty cool, but there is one thing here that is not optimum, is that the list actually throws a SQLX error. But we might want to wrap it into our own error, because sometimes we are going to have module-specific errors, and so we don't want to rely on everything being an external library's error. It wouldn't match. And the way we do that is we go back here, and the pattern that I'm following, and we are going to use the this error, which is going to allow us to remove quite a bit of boilerplate. And in this case, I'm aliasing it to a this error because the error will also be called error. So I don't want it to overlap. It will actually work because it's just a macro, but I feel it's cleaner this way. So then after we have our pub enum error. So that will be our model error with derive this error. And we're going to make it debug as well. And then the way that this error works is you create enum variants, and you can annotate them like this with the error transparent. And then you say where it comes from, and you give a name here. And so that allows that when we do the question mark, the Rust compiler will do the right things because the this error macro will create all of the right transformations. So now we can also do one for IO errors, and those will be the 2 errors for now that we want as a pass-through. Pressing save, everything should be fine. Okay, so now we can go to our model, and then we're going to use the create model, and we can replace this by model error. Now, if we press save, everything should run exactly the same because we didn't test the model error, so everything should be fine. Okay, so we have our list, and now we're going to code our create function. So very similar, we're going to have a pub async. Our function that will be create will take the database, same signature. All of the CRUD function will have the same base signature. And as the data, we could do to do, but that wouldn't really make sense because we do not want the create to take the ID, obviously. So we're going to create a new type, which will be a data patch. We're just going to do that after. And that will return the real to do. And with our model error we just created. And so what we're going to do here is we go back up, and we're going to create our struct to do patch. And the concept here is to have the patch values. So it will be option because everything will be optional. So we'll have the pub CID, which will be an option of I64, our pub title, and that will be an option of string. And now in our create function, we are going to create our SQL statement. Let SQL insert into to-do, and that will be the CID and the title for now. The values, So the best practice we're going to follow is we're going to use prepare statement for everything. And then we're going to return the ID, CID, the title. And the way that we're going to do our query with SQLX is we build our query, SQLX, query as the tubofish. The first one, the compiler can deduct it. And then we're going to have our to-do. We pass our SQL. And then the way it works is we call the bind 1, 2, 3 for IDs, for the CID. So that is the CID, yes, it's not the ID. And then we're going to bind the data.title, unwrap, we're going to return untitled. And that is just for now, because later we're going to see how we're going to optimize it and make it much more dynamic. And then after, what we're going to do is let to do query.fetch 1 this time. We pass the DB, the await, question mark, and then we return the to do. We press save, everything should compile. And now we can go to our model to do test, and we're going to create a test for our create. So we're going to do a create. The fixture will be the same. So we're going to have the database, and we're going to have as a fixture, we're going to add our data fix, fx, which is for fixture. That's the little convention I follow, and is going to implement the title and the default. And actually, we might have forgotten here to derive with default and clone. Now we go back to our test. We're going to do the action of the test. Very simple. To do create the DB, and we're going to clone the data fixture such as we can use it later. And then that will return the to do created. And as a check, for now we can just println, empty line, simpler to spot, our debug, and then we have our to do created. Press save. We forgot to import this one. Press save. And now everything works. And we have our data here. So pretty neat. So obviously we don't want the println, and we're going to assert the value. We can make sure, for example, that the to do created ID is greater than or equal to 1000. So that is what we've done in our database. And then we are going to check the title from the fixture with the title that we just created. Press save, and everything should pass. Okay, so one thing we didn't do is to implement the status of our to-do. And it's a custom type, so we need to do a little bit of custom work. So if we go back to our todo.rs, we're going to create a pub enum to-do status, and that will have open and close. And the design here is just to put it back here, status, and also on the patch, like that. Now we need to annotate the to-do status with a couple of annotations. So the first one, we need to tell SQLX that that is a type. So the way you do that is SQLS type. We're going to have debug, clone, and also partial EQ and EQ. And that allows to do the equal and comparison. Then we need to tell SQLX to map this to the database enum that we had created in the SQL file. And for this, we use the SQLX macro with the attribute type name, and then we pass this value. And that is the name that we had in our create schema.sql. And lastly, here we're using uppercase to follow the Rust convention, but in our schema, we're using the lowercase. So SQLX has another macro for that, and we can rename all of the variant lowercase, and that will put everything lowercase. So now what we need to do is to make sure that when we are getting the data back from the database, we are going to add this in the returning. So in the create, we need to add status because that is needed to be able to create the to-do object. And the same thing here when we do the select, we need to make sure that we return status as well. The order doesn't matter. Yeah, SQLX will find its duck. So now we press save. And everything should work as before, but with a status. So this means that now if we go back here in our test, we can actually do an assert equal. So the data fixture is going to be none because it's going to be the default. We're not setting up. But in the database, we have default of open. So here we can have a to-do status open. We import the crate. And we're going to compare it to the to-do created, the status. Press save. And it's almost too good to be true. Everything is working fine. So now if we go back to our todo.rs, there's a couple of things that we can do better. First one here, that is a big one. This should come from user context. And we're going to see later with the security layer how we're going to add user context to these methods. And then what we need to fix as well is the SQL statement. Right now we're using static string, and this obviously doesn't really scale. Because for example, we just added status to to-do patch. We had to add this to our select here as well. And in fact, we're not even taking it as we are creating the object. Even if it's part of to-do patch, we're not creating it here. So you have two ways of solving this problem. One is by using an ORM, like for example, diesel or something like that. And that will tie your data structure to your schema, which might be an option if that is your pattern. The other one is to use a SQL Builder that gives a little bit more flexibility of mapping your SQL queries that you build with a builder pattern into your struct. And that is what we're going to use today. And actually, I'm creating one right now and it's still in experimentation phase. It's called sqlb. But again, this is completely optional and you can use whatever libraries you want. So the way it works is rather to do the query like that. What we're going to do is create a variable sb SQL Builder, which will take our sqlb, insert. The table will be to do. The data will be data.fields. And we're going to see later how we can make sure that to-do patch implement that. And then the returning will be an array of string that needs to match the to-do structure. That will be ID, CID, title, and status. And then that will return insert SQL Builder. And our insert SQL Builder has a similar interface than SQLX query, and that is fetch one. So that will work the same. And we can toggle the inlay off. And so to make sure that data implement fields, there's a couple of things we need to do. First, any member needs to be bindable to SQLX. And by default, I64 and string and all of that are. But since to-do status is a custom type, we just need to add something else. And that is our sqlb bindable macro, which basically will make sure that the to-do status has the right implementation to be bounded as a SQLX value. Now that we have that, we're going to back to our to-do patch, and we're going to add another macro, which is going to be a sqlb fields. And that will give the information to the SQL Builder about the properties. It will only get the values that are defined. So like this, a patch will be a true SQL patch. So now if we go down here, we're going to make sure that we're going to import the trait as field. And now, before we press save, we need to make sure that the data has a field CID. Because remember, before we had it hard-coded. So what we're going to do is make sure we go to this place, and when we have our data fixture, we'll add the CID. Just for now. We're going to change it later, actually. And we go back to our todo.rs, press save, and hopefully everything works. Now, we do not want to have to-do patch having the CID, because the CID should be a matter of the model access controller, and the caller should just pass the user context by our design and shouldn't have to pass all of this administrative data, which is the creation time, the creation ID, and then later the modifier ID and the modifier time. So the way we are going to do that is first we are going to remove CID for the to-do patch. So that will prevent anybody to pass it as a value. So now we have the compile error. So we're going to have to remove that from here. And we go back to our todo.rs. But now we need to make sure that we're creating it. And that is where the power of a SQL Builder is. I can have a model like this where I have my mutable fields. And that will be the data fields. and I can add a new field. And the way we add is with a tuple. The first one is the column name, and the second one is a value. So here we're going to hardcode it to 1, 2, 3. Then we pass into, and now the data, we're going to pass the fields. And we press save, Command Option save to save all the files, and then boom, everything passed. So now we are going to remove that, press save, and then we can use our SQL Builder here. So in order to do that, we're going to have a let sb equal sqlb select. The table will be to do, and the columns will be the same as above. And now rather to call the query, we can just do a sb fetch all, has the same name, and we press save, and everything should work fine. And it doesn't, and that is the cool thing about the unit test. We just realized that we didn't do the order by. So if we go back up here, we are realizing that actually the order by doesn't match. So now what we can do is order by. And the way that right now sqlb works is we do exclamation mark for descending and then ID. Press save, and then boom, it works. Now we can remove that. So this begins to look pretty good. Now, one thing that needs to be fixed is this hard-coded value. And the pattern we're going to follow is that any model action controller will have to take the user context, which will have the user ID at least in it. And that will be the responsibility of the security layer to make sure to create the right user context. And when we're going to have a web layer or even some asynchronous job layer, that will be from a token. And so we can move to our security file. We will be creating our module error later, so I want to make sure that we have that. What this security module will export for now will be a struct, and it's going to be very simple for now, but after you can make it more and more advanced. So it's going to be a user CTX, and for now we just have a pub user ID. And we won't even have the user ID in the database for now, but we'll have everything ready, such as later it will be piece of cake to add it. And so now what we want is a method, which will be async, because it will need to ask probably the database or some services on the backend. And that will be a UTX, user context, from token. The token will be a string. So later that will be a HTTP only token for the browser. And will be a result, user CTX. And we are going to implement the error of the security module here below. So now on this module, we're going to put everything into mod.rs, but later, as we're going to add more code, that might split in other files. But right now, we're going to put the error here. So that will be our error enum for the security. And inside, we're just going to have our custom enum, which is going to be invalid token. And right now, the validation is going to be very, very simple. So we're going to do a match token, which is a string. We're going to parse. We're going to specify the turbofish that will give the type information to the method, such as you can know which type to parse to. And then if it's okay, we're going to return the OK of user CTX, user ID. And then if we have an error, we don't really care what it is for now. And we're just going to return an error, which will be our error below, invalid token. Press save, nothing should change because nobody is calling it. But now what we can do is add the user context to all of our to-dos. So the way we're going to do that is here, UTX. So the convention is we're going to use UTX for user context, and that will be a reference of user context. And then we're going to do the same thing for list, because in fact, later we will use the UTX as also access control. So having the access control at the data level makes the whole application much safer. So now obviously our test doesn't compile anymore. So what we're going to do is, as part of the fixture, we're going to have a let UTX equal UTX from token and 1, 2, 3. Don't forget to put the await. And then we need to make sure to call our method with a reference of UTX. And we're going to do the same thing for our to-do list. And here again, reference of UTX. Command option save to save all the files. Everything runs and everything works. So it's pretty cool. A little first security layer, almost nothing, but at least the structure of it, and all our tests are working fine. Okay, so we're going to go back to our todo.rs, and we're going to finish our CRUD API. Before we do that, there's one little thing that we can make it a little less redundant, and that is the table name and the columns. So the way we're going to do that for now is going to be using const. It's going to be very simple. We're going to do a to-do Mac. We're going to put it in another block just to be clean. And then in bigger projects, you can even have your to-do Mac, even if it's not an object. Your to-do Mac struct can implement associative function trait. And that will allow you to have more flexibility down the road. But for now, for this size of project, having a const table, and that will be a static string, and that will be for to-do. And then for the columns, we're going to do very similar. So that will be our columns. The type will be a static of static strings, and the values are just going to be these ones. And now rather to have to-do table, we can have self table. And here, rather to have this, we can have self columns. We can do the same thing for the list. And now we can press save, and everything should work exactly the same. So now we can create our get method, which will be a database. Take the DB. We're going to do underscore UTX because we're not going to use it for now. UTX. And now it's not going to be the data, obviously. It's going to be the ID, which is going to be I64. Result, to do, and the model error. Very similar. SB equal SQLB select dot table self table dot columns self columns, and then we're going to use the and where equal the column name ID and the value ID. Now we get our to do, so we're going to do a let to do equal the SB, and we're going to do the fetch one, the DB dot await question mark. And then we're going to return our to-do. Press save to make sure everything compiles, and we'll do the unit test a little bit later for this one. And now below we can do our update. So it's going to be very similar. We do our update. We're going to create the SB. And so the update is going to take the ID and the to-do patch. So very similar. We do the update, the table, the data.fields. Then on this time, we're going to do the where as well, and we're going to do the returning. We're going to execute. So it's going to be a let to do equal SB, and it's going to be the same one here. And then we're going to return the to do. Press save, and everything should compile. So now we can go to our model to do for the test. So we're going to add one for the get, and for the get, same fixture, and then the action here for now, but we're going to just query the one that we have in our dev seed. So we're going to do a let to do, and we're going to do a to do Mac, get our DB, our UTX, and the ID will be 100. That is the first one, which is the latest one in the list, dot await, question mark, and then we can do our check. We're going to check that the ID is 100. And we can test also the title, and we know that the title is going to be to do 100. And the status is actually close on this one. So we do to do status, close, status. Press save, and now we have the tree test, and the to do create is okay. So everything looks pretty good. Okay, so now we're going to create our to do update test, and we're going to suffix it with OK. We're going to see why later. And then we're going to add our fixture. So we're going to do the initDB, the UTX, our data fixture. And then we're going to create our new data as a data fixture. And then we're going to prepare our update data fixture. Then we're going to do our action, which is just the update. And we're going to give the update data fixture. We're cloning because we're going to use it in the check below. And then we're just going to do some minimum checks here, which is we're going to query the database again. And then we are just going to make sure that we have 3 and then check the ID and the title. We're going to press save. Now we should have 4 tests. And now we have the update OK. So far so good. Now the reason why I have update OK is because in fact here I should have the get OK, which is when we do a get with a good ID. What happens if we do a get with a bad ID? So for example, we're going to copy paste our get and we're going to call it wrong ID. And then we're going to pass an ID here, which is going to be 999. And because we want to test that it fails, we're going to get the result. We're going to remove the question mark because we don't want to fail if it fails, because actually it should fail. And for now, just to see what we get, we're just going to do a println of the result. We're going to press save. We should see 5 tests. And we see our row not found, which is actually a SQLX error. So it does make sense, but we can do a little bit better, because in our code, when we have this kind of error, we really want to know which kind of entity it is. And this is why we wrap SQLX into a model error, such as we can have our own errors if we need to. So to do that, we're going to go back to our mod for the model, and we're going to add a custom error, which is going to be entity not found. And it's going to take the entity name, which is a table name. It will also take the ID as a string. And here we make a string such as if later we want to have other type or compound IDs, everything will work fine. And with the this error package, the way you do it is you annotate it with error and then the message you want to have. So we are going to say entity not found, the entity type, and then the entity ID, which is the first parameter and the second parameter. Press save, everything should be fine. And obviously we still have our SQLX error. So now if we go to our to-do, rather to do the question mark, which will basically return the SQLX error, which will be wrapped into a model error, what we want here is defer the question mark in a way. And we're going to do a map error, which we're going to map the error, and we'll get a SQLX error, and we'll match it. And if we match the SQLX error row not found, then we're going to return our specific error here, which is going to be our model error, entity not found. We give the table name and the ID to string. And if it's an other SQLX error, which is not a row not found, then we're going to wrap it into our model error and the SQLX error variant that we had before. Now we don't forget to do the question mark. And here we could just return that, but we're going to do this way. We're going to press save. Everything should compile. And now, as we have seen, we have our error, which is now entity not found, to do 999. So that is useful information for debugging later. So if we go back to our model to do, and we have the wrong ID, we can remove the println. And here's the way we are going to test it. We are going to match the result that we got here. And if it's okay, that shouldn't be okay. So we are going to say shouldn't succeed. And if it's a entity not found, which is what it's supposed to do, we are going to still check the type and the ID. And if it's another model error, we're going to say that we got the wrong error, and we say which one. We're going to press save. And here we haven't imported the model. So we import model here, press save, and then everything should work fine. So that is nice. But if we go back to our to-do implementation, we're going to want to have the same logic for our update. And so we don't want to do copy-paste here. So what we're going to do is we're going to copy this map error logic. So we're going to create a method that will take the result of to-do and SQLX error, we'll take the static, the ID, and we'll do the work that we were doing over there. So we'll just do a result and our map error that we have up there. Now we're going to replace this. We're going to copy that, Going back to the get. And now result to do is okay. We're going to have our method. We're going to give the result, the self table, and then the ID. Press save. And everything should work great. So now that we have that, we don't want that. And we will return this. Press save and everything will work fine. So obviously we should test the update with the wrong ID as well. But for now, this is a very good start. So now to really show the power of what we have built, let's do another requirement. For example, if we wanted to capture the time where the data was modified, the MID and the M time, we could go back to our SQL. We will follow this pattern here, and we are going to add MID for the modifier ID and the M time, which will be a time zone. And our design right now is going to say it's going to be null on creation, but it should be updated for each update. Now I go back to my to-do, and then let's say that for now, we don't really need to have it as part of the to-do return value, but we want to make sure that we are capturing in the database. So the only thing that we need to do is, as a pattern that we have done for create, rather to have the fields here, we are going to have the fields value, which we will create here, mute fields, and data fields. And now we're going to augment the fields with the CID and CTime. So we can do fields, push, MID, and that will be our UTX, user ID. And then our fields, push, CTime. And here in SQLB, we have row, which allows you to give a static string, which is an expression. So it's still parameterized because it's only static string, but at least you can put expressions. And here we don't forget the into, that's the way the API works. Oops, with that. Now if we press save, everything should work because we haven't changed anything. But if we were going to look in the database, those two fields will be there. So now for completeness, we can create our delete method. So very simple. We have our delete with our UTX and our I64. We're going to have our SQL Builder. We delete, and then we have the table name, and then the colon, and then the ID, obviously. Then we're going to do the fetch one, and then we're going to call the same method that we had, the handle fetch one result, with our table and our ID. Press save, everything will compile. We go back to our model to do test. We're going to add our test function, our delete simple. We're going to have our fixture, same as always. We're going to have our action. Right now, we're just going to delete our to do 100, and then we're going to do the check. So we're going to make sure that it's deleted and make sure that the title was to do 100. So that is to check that the data return has all of the data of the deleted row. And then we can have another check, which is we're going to do the list of the to-do, and we're just going to use the sqlb and making sure that we have one, because now we deleted the other one. We're going to press save, and then all our tests should run. We have 6 now, and everything looks good. And the delete is here. And that's it. So that is the first part of building a TodoMVC from scratch, from the database to the web UI. In the next episode, we are going to code the web layers using Warp, and then after we are going to code the web UI. Until next one, happy coding.